Hi, uh, welcome to the overview of the payloads and structure systems. Uh, we are a part of the SDC society. We are in the satellite design competition for this year, and this is basically how the chassis of the CubeSat will look like. At the top, we will have a hook that will be able to rotate freely 360 degrees. And we could see that we'll be mainly using L-beams for the main structure. And we will be using plates or kind of shelves for putting the system components basically. And this will be the main configuration that we'll be using for the chassis of the Cube satellite. In this view here, we have a better and explained view about what components we will be using and how they will be put together in the Cube satellite. So to start with, as I mentioned before, we'll have the hook with its respective bolts, nuts, and washers. And later, like we have the Arduino Nano that is indicated here. We will have a sensor, the MPU 6050 MU, that will be basically for EOCO systems. We will have four BPW34 that will be used again for EOCO systems. And we will have the Raspberry Pi model 3B Plus that will be used for communications and command. And we'll have another board for EOCOs that will be the other feed LIS3MDL combined with another sensor. And for payloads, we'll have basically a sensor, an ultrasonic sensor, the HCSR04, that will be used in a mounting plate with a camera to detect and to help the arm and the capture sequence to know what to do with the debris or when the debris is detected. And same here, we'll have the camera module plus the servo and the mounting plate for the servo itself. And next, we have the robotic arm that is extended and is capturing the debris. And in the last section, we have the reaction wheel that will be for EOCO systems, the batteries that will be used for power, the stepper motor, and the mounting for a stepper motor at the same time for EOCO systems. So we'll have all the interaction between the systems here, the EOCO systems, the structure systems, the payload systems, and EOCOs, and power and communications. And this is how the satellite would look like when the arm is folded and is not capturing the debris. And here we have a close view to how the detection range will look like. So the camera and the ultrasonic sensor are supposed to be rotating up and down in a range of 45 degrees to be able to detect and later send signals to the robotic arm to be able to capture the debris. And in this view here, we see that the arm is unfolded, is deployed basically. And we see that it's able to capture a debris located in the within distance for this competition. And here we see that the arm is taking the debris close to the chassis, basically. So, and this is the main overview of the systems, and mainly talking about the structures part. And following to this, Alistair will be talking about a more in-depth concept or overview about the payload systems. So.
Okay. Hi, I'm Alistair, and as you can see here on the screen, we have an animation of the process of the robotic arm. But first I will discuss the goal of the robotic arm. The goal of the robot arm is to extend out of its folded state that allows it to fit securely within the sat cube and secure the debris and then fall back with the debris. This arm will be given a set of commands to arrange itself to intercept the debris using the data outputted by the detection system. The first segment of the arm is to fold out, is the one shown in the video here. After that segment of the arm has folded, the next segment, which will be shown in the next animation here. And this will be the arm fully extended. But the extension of the first arm is to provide enough clearance for the rest of the arm to be extended. After the arm is fully unfolded out of the sat cube, the arm will then correct itself to the correct position for interception. The claw, as you can see on the robot arm, will be able to rotate to achieve an angle that would be best suited for obtaining the debris. This is done by the fifth motor. The next motor will be used to open and close the claw around the debris and to secure it. But to prevent any damage due to the claw's rigidity, which helps when securing, foam pads will be inside to prevent any damaging, scratching, or any chips off the debris. Once the debris is secured, then the arm will fold back into its original state, the best it can, taking into consideration the size of the debris. And that is the process of the robotic arm. We'd like to thank you for listening, and we hope you enjoyed it.